Hello and good afternoon, everyone. Really excited to be here in New York and part of the AppNexus Optimize event. I missed the first one in London, so really happy to be presenting here. And thanks to AppNexus and the event organizers to make this happen. So the title of my presentation is Accelerating Insights and Decisioning at Scale. Just to give you some context about what to expect, these are some of the themes that you're likely to hear through this narrative. You'll hear a little bit about our journey and evolution in the data analytics space, the kind of technology and analytics expertise and products we've been able to build over the last few years. So while 5 years back, we started off as performance trading specialists, currently programmatic buying is just one channel or output. We offer much more to advertisers and marketers because of our capabilities. The other thing you'll hear about is the advantages of working with an open platform like AppNexus. Fortunately or unfortunately, we live in a world where there are open and closed platforms. But open platforms give you the choice to innovate, to bring in your own ideas, to build something on top of the platform. And you'll see some of the things that we've been able to build on top of AppNexus. The other theme you'll hear about is what is real-time analytics? What does it bring in the real-time bidding space? What are the sort of use cases and scenarios that could potentially help us with? And how we are trying to use it? So let's set some context. I think most of you might be able to relate to the sequence of boxes if you've been working in the data mining space in any domain. So how do you get from data to decision? You first collect data from different data sources. And from these data sources, you try to derive insights. Insights from data is a little bit like finding needle in a haystack. So you not only need to know a little bit about the nature of the haystack, but you also need to know what kind of needle to look for. So once you have insights, then you start your sort of decisioning cycle. Right? You translate your insights into features. From features, you can then score that on the data that you've seen in the past and generate models. From models, you're able to make predictions. And from these predictions, you're able to make business decisions. Once you're able to make business decisions, you're able to collect feedback based on those decisions that you've made, and this becomes part of your data, and the cycle sort of continues, goes along. So how do we try to implement this in the real-time bidding space? How do we try to use this to predict users who are more likely to convert for advertisers? Right? So let's talk about this journey. Right? So back in 2013, we already had log-level integration with AppNexus. But what we also did was partnered with several data integration partners who could give us more data at an impression level or a user level. So from all these, so you can see a few of these examples here. So from all these data sets, we are able to extract user-level features that we want to use in our predictive analytics. So we had like Hive MapReduce jobs that would translate the raw log-level data into a matrix like this. Right? So you had users along rows, you had features along columns, you had the cells with the feature values, and then you had your, the target variable as, whether the user converted or not. Right? So this is a classic, classification problem, right? And so we started off with using linear classifiers. We experimented a bit with logistic regression. Then, we sort of evolved into nonlinear classifiers like decision trees. Actually, this version we used random forests as our sort of models for our models. And this was actually way back then with our Hadoop technology. So once you had this model built. So this is obviously built on the past data that you've seen about users you've seen in the past. So how do you use this to make your prediction, right? So you have to go back to your recent log level data and translate that back into this matrix form. So you had users' features based on recent data, and then use your models and make your predictions. So in this case, you generate conversion probabilities, the likelihood of a user making a purchase, right? And then once you have this, you have your campaign goals, you're able to translate this into bit modifiers, right? So you had like users that you have generated conversion probabilities on, You had bit modifiers, and then use AppNexus batch segment service to push this back into AppNexus and execute your campaigns. So what did this let us do? Just to sort of summarize, this helped us build a pretty comprehensive picture about our users based on all the information or data points that we had available. But what were some of the downsides, right? MapReduce queries, as you probably all know, are inherently so slow. So it's very time-consuming to translate the raw log-level data into a form that is suitable for modeling and prediction, right? So there was significant delay between when you see a user to when you're able to score and predict and make decisions on. But the advantage is we had like really strong models. Usually the models would generate like really high-performing segments, but scale in terms of number of users we could reach was still a challenge. So what did we do next? So we wanted to make our prediction as real-time as possible, right? So what we did was build something on top of AppNexus using their RTDP. So for those of you who are not familiar with RTDP, it allows us to host instances in AppNexus Cloud that listens to bid requests in real time from the impression bus servers, right? So our RTDP instances would listen to every bid request, and we could have bring in our own bid evaluation logic, or add in our own features in the bid that we could type back to our bid request and send back real-time segment modifiers. So this is pretty much the same as you would do in the batch mode, except that this is at each bid request level, right? So just going back, to the similar flow, this time, we had auction level features. We couldn't do user level features, so we from the log level data we translated that into a matrix again like this. This time, by this time we had evaluated. We had sort of evolved into using Spark and Spark MLlib, and decision tree was sort of our preferred model. So then we sort of flattened the trees, and translated that into a table like this. So you had like feature values and bit modifiers that you would send back to our RTDP instances, and then our RTDP instances would evaluate every bid request, find matching entries against this table, and fire off real-time segment modifiers. And this would and it does this really, really well. At peak rates, we listen to about 1 million requests per second. We had to respond in about 7 milliseconds, and on an average, we do that in about 2 or 3 milliseconds. And it also does like some really advanced features, like keyword matching. So this allowed us to bring in our own, sort of features in the bid evaluation. So this was last year. Obviously, AppNexus has been thinking about a lot of these things, and we had the programmable bidder, earlier this year. So we're working with AppNexus on a migration path, to start using programmable bidder, because it does most of these things that our RTDP instances does. So just to summarize here. What this allowed us to do was do real-time prediction. We could bring in our own features that we could tie back to our bid requests. So things like what we call as macro factors, like social or weather or finance, or our own features like keywords and URL and stuff like that. We were able to use that at a bid request level, and score each bid request. But what we lost from the previous cycle was we lost the user level features. So. But we wanted to push ourselves and see if we can sort of marry the best of both worlds. If we could use user level modeling, but be able to do that scoring or prediction in real time. So this was one of sort of our use cases for real timeliness. But for this to happen, it meant that we had to get data in real time into our systems with very minimal latency. So when we talk about real timeliness, actually there are 3 different aspects to it. One is what I touched about, like how quickly you're able to get data into your systems, the ingestion rate. The other is how fast you're able to query what you've collected, and how fast your query response times are. And the other aspect, which we probably talked about a bit earlier, is how you're able to take actions or decisions on the results that you've seen. So there's sort of these 3 aspects to real timeliness. So we've talked about the first ingestion, need for real-time ingestion, and sort of the third aspect of real-time decisioning. Let's talk a little bit about the second aspect. So let's go back to what I talked about, insights from data, right? And I mentioned that it's like finding a needle in a haystack, and you need to know what kind of needle to look for. And usually, people who are able to do this are people who are close to the business, who understand the advertisers. They are able to decide whether an insight is interesting, whether it's actionable, whether it's useful. These are usually our traders who are sort of executing our campaigns, right? On the other hand, we have these data scientists who understand things like feature engineering, modeling, prediction, things like this, right? So our data scientists would work with our campaign analysts and traders to understand what kind of features from their insights would be useful to use in predictive analytics, right? But the problem was the way our systems were set up was our data scientists would have access to the raw log-level data, and whereas our campaign analysts and traders mainly worked with data aggregated to predefined levels, right? So they would generate their insights from these predefined, pre-aggregated data sets to predefined levels of combinations. So, for our traders or campaign analysts to access the raw log-level data meant that they had to learn tools that they're probably not familiar with. Most of these guys are not familiar with traditional analytic tools. They had to learn languages like SQL or Hive or Spark, right? And for these people, the analogy is like someone trying to learn Parseltongue to speak to a snake, right? I mean, not that snake is, data is snake, but then you have snake bites, data is in bytes. Anyway, the point is we face increasing demand to make raw data accessible to our end users. So we really wanted to build applications, interactive data applications for our end users, so that they are able to derive insights from the data and use it in a very interactive mode. And this meant we had to build systems that would be very responsive to return results and not take minutes or hours to return back results. So we sort of have these sort of three different use cases with real-timeliness, right? So what did we do? We built our sort of real-time data pipeline with all these three aspects in mind, right? So we first started looking at what kind of real-time data we can collect. We built our own impression tracking server, which would collect impression events through impression tracking pixels. We already had our pixels which were implemented in advertiser websites to capture conversion events, and we also had our sort of social streaming real-time data. So all of this data streams through a Kafka message bus, and then gets onto a Druid cluster. Most of you, I think, are familiar with Kafka. It's a distributed high throughput message bus. For those of you who are not familiar with Druid, it's an open source platform, open source by a company called MetaMarkets. They're based here in the US, in San Francisco. It's a generic platform. Companies like Netflix use it, but it's been built mainly with sort of the programmatic buying, selling kind of users as target users. I'll talk a little bit about Druid a bit later, but what this pipeline allowed us to do was ingest data with very minimal latency, right? And Druid is really good at in responding to the kind of queries really fast. I'll talk again a little bit about it a bit later. So on average, the benchmarks usually have like 95% of queries finishing within a second. And then Druid has query APIs that we build our applications on top of. So a little bit about the data that we collect. I mean, I mentioned we built our own impression tracking server. AppNexus obviously have announced streaming LLD. We'll again, be looking to migrate this in the near future. But we do a few interesting things. We tokenize URL into keywords, like apply our own IP to geo mapping. So we might, even when we migrate, we might still do an additional hop to do some of these things. And talked about a little bit about other streaming data sets that we collect. So then a little bit about Druid, right? So I think the best way to sort of describe Druid is if you think of an Excel sheet with hundreds of columns and trillions of rows, and being able to pivot across any combination of dimensions and aggregate metrics really, really fast. Right? And this is what Druid does really, really well. So it's sort of meant for time-stamped event data with lots of dimensions and metrics. Right? What it's not meant for is or what it doesn't support is complex query operations. So you can't do things like create intermediate results or tables or So it's not meant for things like iterative machine learning and things like that. You can't do things like join two big data sets and things like that. But whatever it does, the simple query operations, it does it really, really fast. I mean, this is again a bit about the architecture with Druid. The real-time events stream through it into and get stored in what are called as segments. There's segments here again, like in AppNexus world. But these segments are essentially the unit of sharding for Druid. The typical unit of sharding is by time. So each segment holds data for a specific time interval. And we also have the concept of real-time nodes and historical nodes. So once data ages, there's a handoff process from the real-time nodes into the historical nodes. But all of this is queryable through a single query API, like in a seamless fashion. From end user's point of view, you really don't have to worry about where you have to go to fetch the data. Druid does all of that for you. So. Little bit about the query API that Druid supports. The native API is HTTP REST using JSON, but there are client libraries in popular programming languages, like there's one for SQL, there's one for R, there's one for Python, and there's one for several other programming languages as well. What did we do on top of the query API? We built our own query service, which does a few interesting things, right? So it allows you to chain a sequence of Druid queries, take the output of one, and sort of give it as the input for next, right? And Druid is extensible. It allows you to, write your own custom aggregators, write your own, custom query types, and these all get added in runtime through, dependency injection and stuff like this. And the other thing is the open source community in Druid is really, really good, strong, fairly frequent releases with new features. There's one last month, which allows you to do like ID to name translation and query time using lookups, things like approximate histograms and quantile aggregators. So some really powerful features. So what did we do, with a real-time pipeline? How did we sort of use this in applications in MediaiQ world, right? So this is one of this. This is an example of a real-time dashboard in our data visualization BI tool, where we plugged in, using the Druid, our Druid query service, and this is showing like a geo map of a mobile campaign with impressions, by geo, and that is impressions by timestamp aggregated to a minute level for the last 5 minutes. So this is one kind of application, right? And we are in the process of building an interactive querying for our end users through this app. So what I talked about earlier about making the raw data accessible, as much accessible to our sort of end users, and allow them to do sort of generate more insights, sort of accelerate the insights from the data part. So this is one really strong application of that. We are also looking to build like real-time alerting, monitoring, that kind of stuff with our pipeline, that we have. Now let's sort of go back, take a step back, and see the other interesting application. Earlier, I talked about how we had the user level modeling and batch prediction. Then we had like bid level features and real-time prediction, and how we are sort of trying to see if you could combine user level modeling with real-time prediction. So let's go back to this previous, this sort of similar flow and see how we are able to achieve that. So again, we have actually, yeah, this should be user features. So go back to user. This is typo. So this is user features. Matrix, builder models, we have decision trees, flatten the trees. This time, we translate that into set of queries, right? And these get executed using our Druid query service. The output is a set of users with modifiers, and this again gets pushed back into AppNexus. And currently, we push both through the batch service as well as through our RTDP instances. The reason we do through batch both of these is because the batch one has a latency of about somewhere between 50 to 30 minute interval, so the RTDP is much more real time. But I'm really excited to hear that AppNexus has this in their pipeline about an instance audience service, which means that these other outputs can go away. Now we are sort of able to combine the advantages of user level modeling with real time prediction. Right. So yeah, talked about this. Now let's talk about another interesting use case that we've just started experimenting with. This is using the named lookup feature I mentioned in the recent Druid release. So what we're trying to do is see if we can sort of join conversions and impressions using Druid. The advantage here is the number of conversions that you typically see is in much smaller scale compared to the number of impressions. So if you try to see if you can use conversions as a lookup in Druid, you're able to join conversions with impressions. And this means this we think is really valuable. What Druid allows you to do is simple queries, but what it does really well is allow you to do lots of it really fast. So what we are trying to do is see, as soon as conversion events happen, if you can sort of run several queries across several features or combination of features and try to extract the high information features, and using things like information gain and things like that. So this means that we are potentially able to extract features in near real time as soon as conversions happen. And this, is another. Like I said, this is sort of early stages. This is probably like hot off the press kind of news, but we feel that this is really valuable. So, just to summarize, if you go back, to the first slide that I had about data to decisions, you can see that almost, the time lag between the different stages could be as small as possible. And this lets you to do really interesting things in cases where the real timeliness is much more important than building a pretty comprehensive model or picture, right? But it's also important to understand that not every scenario would need real timeliness. In a lot of our campaigns, we still see that our batch user level segments are the most high performing ones. Also important to understand that the possibility of introducing skewness with some of this real timeliness. And the other thing also to consider or factor in is there's a cost that you pay for sort of real time analytics, and you have to sort of evaluate that against the benefit that you would have or you're going to get. Yep, I'm done. Questions? No questions?
Hello. Hey, hi. You have mentioned about the social and macro factors. Just curious, what are those and how do you get that?
So yeah, good question. That's sort of, again, one of our unique features that we take to market. So in social, the idea is most of the user level or impression level are what we call as micro factors. You're able to tie that back to a user or an impression. But depending on the vertical or the category of advertiser or the campaign and stuff like that, a lot of times we see that macro factors like social media or weather or finance-related influences purchasing behavior. So when I say social data, we use Gineb to interact. I mean, to use collect Twitter data based on combination of advertiser or brand-related keywords, and collect that in real time. We also started experimenting a bit with Instagram and other data sources in the social world. Weather is again is a factor that we have seen has pretty strong correlation in certain kinds of campaigns with purchasing behavior. And the other aspect is I mean this is pretty much a wide spectrum of factors that allows us to decide whether you want to use it or not. Not every single campaign or advertiser we are going to use this, but collect the data and use it based on whether we decide it's going to make a difference or not.